So, hi everyone. I'm Eliza. I'm director and evangelist from Women Who Code Vancouver, and thank you for joining us tonight. I'm happy to have Amy Goldlist, our speaker for the Fireside chat. And when down to her bio, Amy Goldlist is faculty with Operations Management Department, School of Business and Media at BCIT, where she's program head for business analytics. She's data analyst in residence at the BCIT Centre for Excellence in Analytics, and she's a Master in Science in Mathematics from UBC, focusing on Algebraic Number Theory and an MDS, Master of Data Science, also from UBC. She is a co-author of the textbook Essentials of Business Statistics with Ken Black, Timothy Edmonds, and I hope I'm pronouncing this right, Ignacio Castillo, which is available via Wiley Publishing. She's also a co-author on the textbook Business Mathematics, available through OpenEd BC at pressbooks.bccampus.ca/business mathematics. You can learn more about her at her GitHub, amygoldlist.github.io, and she lives in Vancouver, BC with her family. So Amy, thank you so much for joining us tonight. I know it's a bit sunny outside Vancouver, so we're competing with the weather.
Yeah, it's nice outside, which is good.
Awesome. And let's see, so I prepared a list of Fireside questions chat. So see, for the question I had, first one for you is why did you choose to go into this field?
Good question. I actually just wanted to start by acknowledging that I am here on Zoom from the unceded traditional territories of the Coast Salish nations of Squamish, Tsleil-Waututh, and Musqueam bands. Okay. Why am I here? I think I started out in math and I followed different things. I was a mathematician and I ended up working at BCIT, and I know I recognize at least one person here from BCIT. And what happened is, instead of teaching math all the time, they always need people to teach statistics. So I ended up getting more into statistics and teaching that for years at a time until I got very interested in statistics. At the same time, I had a lot of people I know at UBC telling me about this new Masters of Data Science program that they were forming. So I was listening to the people talking about it while they were making that program. And part of me was like, I don't know a lot about coding. I'm a really good mathematician. I know a lot of the theory. I can do statistics, but mathematicians tend to be self-taught coders. And you learn like what you need to get along, but no fundamentals, which doesn't really get you very far. I've always liked coding, but I took a fundamental class in high school and didn't really learn anything real since then. So I thought, well, that will teach me the coding aspects. And I watched, and I didn't go to the first year because I decided I was too busy that year. But then for the second year of the program, I applied and decided to take a year off work, where I was mostly doing math and statistics, and retrain in data science and go back to school all year. So that was a lot of work. If you guys are students, and I know some of you are, it was more work than I imagined. I thought it would be easier to be a student because only you are depending on you and not the entire class. But it was more work, and it was a lot of following other people's instructions. But I learned a lot of things, and what I wanted, which was more fundamentals of coding, especially in R and Python, which I knew a little bit about R and a little bit about Python, but not a ton. So I learned those, and if you practice something every day for a year, you do get really good at it. So I
developing that
learned
muscle
a lot there, and then kind of went back to BCIT and kind of changed my role and went more into analytics at BCIT.
Okay. I'm just going to follow up on that question.
Sure.
For you, has there been like a learning curve, or maybe like the biggest challenges you've seen from when you were like a student versus like an instructor and like helping with this program?
Let me think. In analytics, there's a lot to learn, especially in data science. And this is, I think, a lot of data people here. So to be a good data scientist, you need to be able to code, and you need to be able to code properly and understand the fundamentals enough to work with other people. As a mathematician, you code with yourself, so you can name every variable X followed by a number, and that makes total sense, and you can do things your own way. And that's how I learned, was doing things my own way, or the way of my supervisor when I was in grad school. He didn't like languages, and he coded in machine language because it was easier for him, because he was quite a bit older than me and near to retirement. So he trained in the 60s before any of our modern programming languages existed. So I probably picked up bad habits from him. So you have to know how to code enough to be able to work with other people, even if you're not a software engineer. You need to be able to understand math and statistics enough to pick up new algorithms and understand what's going on in those machine learning algorithms. So a lot of people using them don't really know what's happening, and they don't know what assumptions they should be following. There's a lot of like mathematical assumptions, and you do need to understand what they are to be able to use them and know if the algorithm you're using is correct for your data. And the last thing is, you need to be able to actually work with data. That was actually the surprising thing for me, was that my favorite part has always been the data wrangling part. And I think learning that that was not standard, that most people hated getting data in like 15 Excel sheets and trying to make something of it. And I like that part. I find that to be a challenge. And that the data wrangling, which I like, is I think the hardest part to teach. You can teach statistics and you can teach computing, but being able to, you can learn techniques, but how to look at a bunch of data and a data set and see, or a bunch of them, and try to see what it's supposed to be and how it will work, is something that I'm learning how to teach. And I can see at least one of my students that I've been trying with, but it's difficult to kind of communicate what I do there. So that is, I guess, a challenge.
I'm going to like pivot a little bit, because you mentioned that your advisor did machine language, and this is more like, women leadership. So for you, like, how important was for you to have a mentor to grow as like a leader or in this field, and who are they, if you like to share?
I'd say it's pretty important. My first supervisor in graduate school was a big influence on me, and he was a really good mentor. He was a kind person and taught me a lot about mathematics. And he taught me how to code in was GP Paris, which is a language that probably no one has heard of, but it's very useful for algebraic number theory because it has all the prime numbers built in. So if you want to count things by prime numbers, it's got you covered. And that's about all it does. And I learned that because I needed it for my own work. So he was a good supervisor. I will say that when he retired while I was still a student after I got my master's, and I had stayed on in graduate school, and I ended up with a supervisor that I did not work well with. And I think that really made things hard. I realized that without a teacher, like a mentor who did believe in me and who thought that I was doing well, I did not want to stay in graduate school. So that would be important. I'm trying to think. I guess when I started at BCIT, our program head at the time, Laureen, mentored me. So I ended up getting mentored by her. She is a computer science, started as a computer scientist, and then did more statistics and math adding on. So she's a computer scientist, and she helped me out a lot when I was starting to teach and showing me how to teach, and more so teaching me how to do administration and be in charge so that I could be a program head and run things. So that was a good thing for me to have her around.
Do you have any like mentors or leaders that inspire you?
In data science, I will say one of my instructors, my professors at UBC, Jenny Bryan, who is she's very on Twitter, and she's an R person. She was one of the founders of that program, and I got her for a data wrangling class. And then I think she's left the program and is now working with our studio, and I'm not sure she's at UBC anymore, but she was just a lot of fun. And is a person who is also really interested in making data look clean, and was a person who got her start fixing other people's Excel sheets, which is a thing I do. And she brought in a lot of kind of fun examples from her life. She had an example where her children were supposed to walk to school, but they have compass cards. So she showed us this script that she wrote that would like pull all the data from their compass cards and arrange it in a way and give her a report that showed her how often they were actually walking to school and how often they were taking the bus. So she could run this report, and it automated the whole downloading, data cleaning, and presenting it so that she could show her children that she knew they were not walking enough and getting enough exercise.
Making tools to make our life easier or be more informed.
And I liked that idea of it doesn't matter how kind of silly a task is and how easy it really is. Like looking at compass data is fairly easy. If you've looked at that, if you have a compass card, Vancouver, if you look at it, you can see exactly what day. But if you were going to look at it every month and say, how many days did I take the bus? That's something worth automating. So you take something and something that might take you 10 steps. If you can get that down to 1 or 2 steps, that really makes your life run smoother.
And you have like a very like simple answer, like, is it this much or is it like,
yes,
this little? So
yes. And I guess the answer there is also, what are the questions? Data's big. You end up with these giant data sets where there's like a million questions to ask. So being able to come at it with one question and be able to answer that, which was, you are supposed to walk to school 3 days a week. How often is that happening? Is it or question, then what is happening? And then you look at the data. And sometimes it's easy to look at a data set and just think, what's happening? And that's not, it works. It's still fun.
It sounds like interesting versus like saying like, how many steps like are you taking on a pedometer to track that information?
That's true. I guess I have my fancy little Fitbit. I could download all that data and look at how many steps I walk. One day I would like to carry my phone around with me everywhere and then check it with the watch and see if they're the same. I have a theory that they don't count steps the same way. So I would like to be able to prove that.
I think that'd be a fun project to see. Maybe that should be like our next event.
I probably have to get like a manual pedometer that you attach to your shoe, because I know those ones are very accurate. And then I need an accurate baseline. So
okay. I'm going to like pencil this down. So to remember to ask you like in 3 months from now, how's that going? Okay, pivot again. Another question. You mentioned, I think, Excel twice now, and kind of shared your opinion about using data from Excel spreadsheet. But can you give it more in context of if it's from what I put in my notes, like operation admin versus like business product teams who want the data to be accessible via monitoring?
Excel is terrible for tracking changes, data quality, and very big data sets, and honestly dates. But it's very good for, there are people that I work with that are not going to work with anything else. So in an ideal world, maybe the only reason you would use Excel would be to open up CSV or tabular data, explore it. It's actually really good for very quick data exploration. Pivot tables, once you get used to them, you can click and drag and do lots of different things and see what's going on very quickly. Filter, get a snapshot of the data. So ideally, you would use Excel only for opening up a data set from somewhere else, exploring it, and never making changes and never storing data permanently there. But that's not the way the world works, because I work in a school of business, which means nobody knows any coding languages, sorry, except for the tech people. So if I'm working with somebody and we track part-time studies classes, so I help organize all of our night school classes. Okay. There's a 0 chance that I can get a report to me in something that isn't an XLS file, not even an XLSX, which is the post 2003. It's going to be the pre 2003 Microsoft format, because that's just the way things work. You have people been in the role for 30 years and it's never going to change. Maybe one day eventually, but it's better for me to be able to take one of these XLS, especially because they come out of our database. It only gives you XLS or PDFs. Those are the formats, because we have some very old databases. It's easier to take data out of an XLS. So for me, it was better to write a bunch of scripts that take the reports out of an XLS, do what I want, and then spit it out as another Excel document, because I can't email someone a CSV without them getting upset. And I can't email somebody a like data frame or an R script, but I can make a script that opens an Excel file and saves it as an Excel file.
It's a useful tool. Yeah.
Sometimes that's the best that there is.
Okay. I may be dating myself this question. I like computer internet history, but do you think the world, like, it's a very random question, but do you think the world would look different if we were still using like Lotus 123, which is like the predecessor for Excel for anyone?
I don't think Lotus 123 was all that different. Like Excel builds on Lotus 123. Microsoft, in building Excel, basically used all the old, there was a pre-Lotus 123, and I can't remember what it was called. And I will date myself because I am older than you. I took a class in Corel spreadsheets when I was in junior high. So that was a pre-Microsoft. And then I'm pretty sure Microsoft kind of absorbed that. So a lot of these precursors all got absorbed, and Excel took on the best and the worst of everything. Microsoft's strength, in my opinion, and their weakness is that everything is backwards compatible. So if somebody made a weird programming decision in 1985, that's still in the Excel code. There are some very weird things when you're trying to code in Excel. You're like, why would you put quotes around a greater than sign? That makes no sense. And the answer is it made sense in some sort of 1993 or so technology. And to make everything backwards compatible, it's still there. On the other hand, I can open old files and they still work. As opposed to, honestly, our has been upgraded in our studio. I've opened up older things, and I know my partner, he has been a long-term R person. He's now getting upset because like he used old versions of dplyr and now it's been updated. So things that he automated years ago, now he has to go in and fix the scripts.
Right, the backwards compatibility.
Yes, so that it isn't backwards compatible anymore. So my Excel stuff still works.
Okay. So I'm going to hop on from that question to another one. You've already mentioned, like, backwards compatibility. It's an obstacle, but in your opinion, what do you think are some of the biggest obstacles that companies, or maybe just like students, like face when creating the data-driven culture, or maybe a data-driven mindset?
I'll try to think from my work, because I mostly work at BCIT, so I'm academia. It's hard to get people used to making decisions based on data and to use like tools to do that. So I know we have a lot of, one of the things that it's not my job, but I work with the people who do timetabling. So if you are a student in school, and we do a lot of standard timetable where you're just handed a timetable, trying to get everything scheduled in all the classrooms correct is the process is everything gets rolled over from last year, and then a bunch of people manually go in and change things. They look over and they're like, this doesn't work, let's manually move it. So a few years ago, some of the more data-driven people came up with a program. So we have a timetabling program that anybody who works on timetables can log into this, and it can run through and optimize check rooms, do the things you want it to do. So and then instead of when you decide to change a class, you don't have to put in a request to a person who then puts it through in a database. You can do it all. It's all automated.
It's automated. Yeah.
Getting people to use the system when they are used to printing out 100 timetables and using 15 colors of highlighter, and that's their process, is difficult. Like there's people who've been doing this and they're like, well, I don't want to do this on computer. I always do this on the table. My way works. So why should I bother learning a new skill? So getting people to use that, and it really, it saves a lot of time.
It's like the transition planning
Yeah.
when you're.
So that would be, yes, this digital transformation is the word of the day.
I know, like it's helpful, like just addressing like their pain points, and then hopefully that convinces them, oh, this fixes a lot of hard things that the person personally go through, and then they become like an advocate. But it's like it's like a process, right? Like you said, some people really love tangible and the smelly felts.
People like I mean, I miss my pens and my markers and things too. I can't believe I'm saying this. I miss sitting down and grading papers on paper because I used to sit on my couch. I have a lap desk and I'd put in like some stupid TV show in the background and sit cross-legged on the couch grading with red pens, my pens, and writing things down. And I was so used to that. And then with the obviously the pandemic, and we moved online and we did exams online. And now that we've done that, I think some exams probably will go back to paper, but for at least anything data related, I mean, I can test someone better on a computer than I could when I had to make somebody write about what they would do on a piece of paper. So I don't get to grade that way anymore. I have to sit at my desk. I have to have my
computer screen.
And,
I feel like I just had this conversation a couple of days ago. I finally finished our taxes, but my mom wants the big paper pack, that they used to give out from Canada Post. And I'm just like, well, I'll just print it out from our printer and watch our toner turn from light black to brown to.
You can write. It's probably too late, but you can write the CRA and they will mail you a package for free, but they don't give them away anymore.
Okay, I'll remember that for next year because I'm in charge of taxes.
Saying that, there are a lot of online things that you can do for free where you can do your taxes. It's all very basic arithmetic.
Yeah.
Doing it by hand is a little redundant, but fun.
But yeah, it's just having that tangible if you're comfortable with it. Just convincing. Yeah. Okay. Pop to another question. You mentioned BCIT. Would you like to describe more about the graduate certificate in business analytics at BCIT? I guess.
Sure.
It's like, the other perspective, like you were before a student in data and now like, instructor, and now it's like, when the program heads, like take this question however you want to answer it.
Well, I should say I'm proud of our certificate. Yeah. We have several different data related programs at BCIT. In different ways. We have a certificate in applied analytics. We have some diplomas with options in predictive analytics and AI. We have our new AI management option, which is a diploma in the School of Business, as well as our graduate certificate in business analytics. And that's the one that I'm program head of. I will tell you, I became instructor in that program and I became program head 1 month later.
Wow.
So it wasn't really a very long transition. It was supposed to be quite a bit longer. And then our previous instructor, a previous program head had to step back for family reasons. So I took over much sooner than I had. I think I had kind of thought maybe I'll do this one day, and it came very quickly. So our certificate it's different than the data science program I did. So I know like there are lots of different programs. The one that I chose, this Master's of Data Science, is through statistics and computing. And that was, I mean, I come from a science background because I'm a mathematician in science. And maybe in retrospect, I think business would have been like, there is a business analytics program through the School of Business. And actually one of our faculty members is doing that now, and hearing back from her, it sounds like a really great program. So I could probably use more of the business because I was more of a math person, but I think I was focused a lot on the computer science. I've always kind of felt that was the hole I had, was I can code, but I couldn't code efficiently or collaborate. And those are key. Academics can get the answer, and I've always been able to accurately code and get an answer, but maybe my code took 6 hours to run instead of 10 minutes. And maybe it was really indecipherable to anybody who wasn't me. So I was focused on that being part of computer science. Now I'm getting away from my sentence. Let me think what I was saying. Right. So that was a full-time program. So I went on leave for my job. BCIT sponsored me, which was made it easier for me to choose. I know a lot of people pay for these. They take like a whole year off of your life and then paying tuition on top of that is a big investment. It wasn't as much of an investment for me because I was being sponsored as well. When you get professional development money to go out, you're basically guaranteed your job for a year when you get back, but you also promise that to them.
Right.
So everyone else was looking for work and I was not. I knew that even if I decided to leave BCIT, I would have to stay in place for at least a year or pay them back a lot of money. So it wouldn't have been worth my while to leave. So I knew I wasn't going to. So I got to be full-time, not doing anything else, just focusing on this. I did do some work on the side. I was finishing up our statistics book that I'd been writing, and I was still doing a little administration and part-time studies, but I would cut my work down dramatically and was just focusing on school. And it was 4 days a week in class, and I spent all day Fridays and most of Saturday doing work as well. Like I worked a lot. Our grad certificate is a part-time program. I will say, if you're thinking of applying, it is classified as full-time for getting student loans, and hopefully international students, we're waiting on that. We'll find out in May if we get approved, and then it'll be full-time for international student visa requirements and for that. But all of our students, most of our students work, and I think most of them are working full-time. So they're doing 1 night a week in person, 1 night a week online, and work outside, group work and individual work outside of it while balancing a job. And some people have children as well. I had 2 small children when I went to school, but I also had a spouse who was helping taking care of them and no other job. So I got to really focus on that. I think our students, they work really hard. They get a lot out of it, I hope, but they work hard. It's also not a data science program. So while they do get to see a little bit of R and a little bit of Python, they spend more time with Power BI, with Excel, a lot of time with Excel, and with learning like the business cases, which is, it's not as much knowing how to use the data, it's how to talk to everybody, how to present things to management, etc.
How to answer questions.
Yes.
How to derive insights.
Yeah.
Have you seen question? It's the biggest challenges for students, or what are one of the biggest things, like the opposite, maybe biggest strengths they get from a program? Like you see them become much more confident, like, you know?
I think people do quite well. I think people become more confident with their data skills. Most of our graduates get employed fairly quickly. That's our stats, so that's good. They do get jobs, they do get employed, which is good. I think, at least I teach the first class, so I don't teach all the courses. I just teach the first one, which is the intro and a lot of statistics. I would say people struggle with statistics. That is always the thing, that there's only a few students that come in really like, I am good at statistics, I know what I'm doing. And in my MDS program, that was the same. People struggle a lot with statistics for whatever reason. I mean, there's a lot
it's a different like hat to wear, right?
It's a different hat to wear. It's math, and that to really understand it, you need to have a lot of that mathematical and logical mind. But unlike math, where there's one answer most of the time, this is more like a range of answers, or probably an answer, because it's probabilities and a collection of algorithms and things that you can do. So it's less formal than like a formal mathematics. The notation in statistics is really confusing. It's the most confusing.
Take your word for it.
Yeah, if you guys took it, the notation is confusing. The words are confusing. It's a whole new language. So, and if you don't use it all the time, you forget it.
Oh no, it's like the word. It's not like riding a bicycle.
Get it back.
All right, it's good to know. So, go back on something you mentioned previously. You said you did the Master Data Science at UBC. Would you like to talk more about that? And I guess how do you like someone who wants to be a data scientist, or like who is one? Like it's that program? I guess the value you received from it. I don't know, I'm just like throwing words.
I think it was valuable. I learned a lot, and I went in thinking I knew a lot. But it is, so it's offered jointly by computer science and statistics, which is there are no business people in it. So that is the piece that is missing, is the making a business case, being able to come up with return on investment, understanding when you should refine an algorithm because you should spend 2 months making this better, and when you're not going to get any money out of it, and how to present. So I'd say there was no business piece, but you learn a lot. There's a lot of machine learning, but you do the full series of statistics through kind of elementary, a little bit more advanced, a couple of classes in regression, time series, etc. So you do get to learn a lot of statistics as well. And coding, it's R and Python, and then there's some databases, so some SQL. And you do learn all the skills. At the end, there's a capstone project, which was, I want to say, 1 month full time. Maybe 1 month and a half, or it's now several years ago, and there was a pandemic in the middle. But you work in a group project on this. And yes, it's one stack class per block. I can see there's someone from there. The capstone project, as well as there was a few of the classes were based on like coding practices in a team, like group work. And I can't remember the name of the classes, but basically you would work as a team and learn Git and GitHub, which I found frustrating at first, but once you get used to it, it's pretty good. But most of all, the idea was how you would get together with a group of people and decide how to make decisions and decide how you change the code and how are you going to do this. Software practices possibly was the name of that, how to do testing, that type of thing. And that I found really useful because I don't think I'd seen that anywhere else, where you sit down and learn, okay, this is how you make decisions. Here are ways that you could collaborate, and here's you make decision on processes. And I'd worked on things before. I worked on the stats book. We kind of built our own processes because
You're agile.
There was an earlier version with 2 of the authors and possibly somebody else. And then the 2 of us came on, Tim and I, to make it a smaller book. So to take this giant kind of technical book and make it appropriate for colleges and polytechnics and the level of our students, and make it a little more friendly and a lot more Canadian. So it was mostly the 2 of us working on it. And we had to come up with from scratch, okay, what file system are we going to store files in? How are we going to name things? Who works on a file at what time, and how do we let each other know? And I think like it would have been great to have known, hey, there's formal ways of deciding all of this. And he was really good because he is a computer scientist, then turned to stats. So he was like, this is how we will name our files. They will be having start with the date, year, month, day, so that when we sort them, they will be alphabetical. I was like, okay, which works.
No, I think I've seen that maybe on Twitter. People say like time zone and dates are like the most confusing thing among like different countries or languages. So knowing that beforehand would have been like useful.
Yes. So no, he was very, he's an old friend of mine. So he was very firm. He was like, we will always use year, month, day. And I was like, are you sure? And he's like, we will always do this. And he trained me, and now I can only do it that way. Because when you sort everything, it sorts properly.
It's like the data cleaning.
Order is the date order.
It's awesome to hear. That actually hops into another question I had. You can answer this like as you will, but like, chances like, what's your perspective of like a data team in companies, you know, where main product is not data? Like, should data be a leading or supporting role, or just like helping to build that data mindset? But yeah,
it's good to build the data mindset, but if data isn't the aim of the company, then you have to be, I think that the data people have to be mindful that everybody won't change their processes to suit the data team. So this is what I kind of want to say about Excel. They're going to use it. You just have to learn how to work that into your workflow And maybe that means you kind of gather up all their Excel files once a month and pull everything together and then spit it back in the format they want with today's date on it, so that the versions don't drift apart, which is what they do. Everybody keeps an Excel sheet on their own computer, and then they add new data to it, or they change things and they drift apart. And then suddenly you have to reconcile them. And you're like, I have no idea what's going on. So you can try to make people use even SharePoint, where they can still use Excel, but at least but in a tech company that's new and in a startup, I think you can probably force people to use whatever tech stack. In an older company, that's harder. I am in a public company at BCIT, which is a union environment. So you literally could not force people to use specific things. It is impossible. As long as the tools that they're using obey the privacy standards, then people will use what they use. So I would say it would be great if data took a lead, but I don't think it's realistic to expect it.
Okay, so just like accommodating, but also recognizing where the pain points like would be, and getting people to use and change.
Yeah, probably finding people's pain points and fixing them is the best way to get people on side. Even if that is, I get this Excel file every week and there's a bunch of blank spaces, or I have to spend a bunch of time creating a report every month. Even things like mail merge and Word are like a mystery to people. So sometimes just showing them that like, oh, but you could use this new tool and then you could just click this button and everything will be created. You can try to get people on side that way.
Okay. It's good to hear. Another data-ish question I had, this relates more to like your master data science. So you're like, I guess now I can say you're kind of like a data leader, data center. Yeah. So the question I have is like, how can you use data analytics to help your like organization reshape the business, identify emerging opportunities, managing risk? Or I don't know. It's hard to say whether that would be related to like the BCIT program versus UBC, but you can answer.
Well, I mean, hopefully, there is some business elements. I'm looking at the chat.
Okay.
I'd say that would be what business analytics is all about. At least in my opinion, what really makes business analytics different from data science or data analytics is that everything you're doing has to do with your company's bottom line, managing your company's risk, making better decisions. So the idea is you're not spending time playing with data unnecessarily, though that still has to be a part of the job. Without exploring it, you need a little bit of time of free exploration and looking things through and just trying to follow your gut and see if there's anything there. But most of the time, you're not improving things for the sake of improvement. At like a big tech company, they're trying to make their search better. Facebook is trying to keep you engaged longer. Most businesses, you're only trying to keep people engaged longer if you know that more engaged customers spend more money or stay customers longer. And you need to be able to quantify that. So you're not trying to make the best product you can, much as that would be nice. You're trying to get the best return on your investment. So you shouldn't be spending a lot of time on things unless you're getting something out of it. Saying that, there's a lot of businesses that still make decisions by gut instinct and without any data. And a data person coming in can like really get huge gains very quickly, which is actually some of the student projects I've seen from some of the business students. Actually, the operations students sometimes go in and they can save a company like $800,000 or $1 million because nobody had ever thought about like using math to solve a problem. One former student told me about, he was working for a shipping company, and the decisions are made by sea captains in a boat shipping company, and they fill up on fuel when they are empty or when they feel like it. And he was like, well, why don't we use linear programming to just figure out based on fuel prices and the weight of the ship, because the more fuel it is, the heavier it is, etc.
Okay.
To
They
come
can
up with an
quantify it.
optimal time to refuel, because fuel costs different things in different ports, different amounts. Heavier boats can't maneuver very well in certain areas. I am not a boat person. He did understand that. So he came up with some sort of like easy linear programming model and saved his company millions of dollars, like very quickly, because nobody had ever thought, hey, let's look at the data instead of just making a decision based on experience. So I think, yeah, there are a lot of things, but unless you're saving the company money or making them more money, it's not all that useful.
It's like having quantifying that intuition or knowledge. It kind of like, it takes years of experience to build, like you're able to do like the formula, right, to solve it. Yeah. I guess another way you could describe just like, those scales they have for like measuring how much liquid or like how much powder it's like when you're baking or cooking, because like there's difference between like European cooking and US cooking, and just knowing that instead of like eyeballing like the measuring spoon or cup.
That's what my mother taught me when she taught me to bake. If you measure everything exactly precisely, everything always turns out. You have to level, and she sifts the flour and makes sure everything is exactly right. But I think I will say, before I went to graduate school in math, I used to work at market research. And back then I found that a lot of the companies that hired my company were often like, they had an answer in mind and they were trying to get data to back it up, but they didn't really know why. So they would often like have an idea and they'd spend money to have a report that backed up that idea, but they would have made it before actually hiring someone. And it was actually pretty rare back then to have someone who would hire like at least my team, or the projects that I got to work on, and I was fairly junior, that would come in without knowing what they wanted the answer to be. So hopefully things have changed. That was like 20 years ago almost. But I did find a lot of people come up with an idea based on gut instinct, then try to pull in data to support that, as opposed to looking at the data to make the decision. And I think that's a hard thing to do.
It's a muscle to build, right?
Yes.
So
you also have to know that your guts are going to be wrong sometimes. And I think that's really difficult.
I think that's true. You're right. Another question. Oh, so this was on Fireside Chat. So, but did you have like a favorite book that you'd recommend, or like a project, or do you have like another? Yeah. Or
well, I'd say for AI and AI in business, and that's a lot of data science. I like the book Prediction Machines. If anybody read that, and it was Avi Goldfarb and Avi something else, two people named Avi, I believe. And that was a really good kind of plain text book about the idea is prediction machines, how having machines that have really good prediction changed the business world. So it was built on business use cases and the idea that jobs won't be eliminated, but jobs will change. So once upon a time, accountants who did auditing would randomly select things and audit them and look over. Nowadays, or in the future, once everything is automated, probably you're going to end up with a machine learning program that looks for anomalies, and anything that looks strange gets audited. So you're not going to be dealing with ordinary things anymore. You're only ever dealing with edge cases. And I think that's a lot of jobs. So I think that book really made me think about those jobs get harder. Bank tellers don't have to do deposits and withdrawals anymore because ATMs exist and have for a long time. You don't need to have your little bank book and write it down and write the little slip the way once upon a time. But there are still bank tellers. And instead of spending like 2 minutes per person taking a check and depositing it, they're only ever dealing with people with difficult situations. So they only ever deal with edge cases now. And I think that's a lot of jobs. All the easy stuff in the middle, that gets done by machines, by AI. Humans have to do all the tricky business. So that was a book that made me think of like, all the tricky, interesting bits that you get to spend your time on when you're not doing routine.
Okay. I feel like I have to follow up with you, like looking up that book online and then seeing if they have it as a library book or as a online book to
I
read.
think it's probably a library book. Well, I know it's an
Okay.
ebook. I don't know if it's a free ebook.
Okay. I'll
Sorry,
definitely
and I'm
look
going
it up
to
after our call.
apologize for blowing my nose all the time because I'm recovering from some sort of virus, which is
Okay.
why I'm isolated at home.
Okay. It's no worries. We're all staying at home during a pandemic, and I know like right now it's spring and some people have like sneezes due to like all the flowers, so it's
Yes.
definitely understandable. Okay, I guess the wrap up questions I have for you. One's like, what would you recommend how women like can help develop their leadership skills? And the second one was, what advice would you give to young women entering, say for the grad school in math or data science, or just like, this
I would
big umbrella?
say to talk to other women. Talk to the other women that are your colleagues and your students and your potential mentors. And don't think of them as competitors, or try not to. And think of them as people that are facing the same challenges. I think when I was in grad school originally, it didn't occur to me that I could go to the very, very few female professors. And I'll say in my undergraduate, I went to King's and Dalhousie in Halifax, and then I went to UBC. Both of those schools had very few women in math, and they still do. I think women in research positions in mathematics has topped out at about 15 or 20%. And it's been that way for like 30 years. Women just don't end up in high up positions in math. I think data's a little bit better, but it's not great. I don't have statistics on it, but it's harder for women. There is a lot of people that say that it's easier if you're a woman or a minority because everybody wants to hire you. That's a lovely thing for people to say, but it's not my experience with actually who is in upper level positions. So it's difficult to take. I'm hoping it's better in grad schools now. When I did my MDS, I think it was probably like 50-50 women and male and female instructors. Everybody was pretty friendly. I did not get, at least I did not experience sexism. I will say in my previous times, it was more pronounced. And I think when I was an undergraduate, that was just the norm, that I was the first woman to do honors mathematics in my program at Dalhousie, and people brought it up in almost every class I was in. They would start saying something and then stop and be like, I should be more polite. There are now women in the class. And then everyone would stare at me. And that hopefully doesn't happen. So yeah, I guess when I got to grad school, I had some like female friends, but it's actually only lately that those of us who went to grad school together are talking about all the like bad behavior we experienced and how some of the professors were fairly awful to women. And at the time, all of us were a little bit embarrassed and ashamed, and we never talked about it. I went out for drinks with a couple of women that we all went to grad school together like 15 years ago. And we all had these terrible experiences. And I'm like, I've been friends with you guys for years. How did we never talk about this? And I think, there's a lot of Me Too and things in the media. It makes it easier to say stuff. And I wish that I had talked to friends and known what was going on in their lives. So I had people that I would consider friends that were having struggles with advisors. There was a lot of advisors that treated their female grad students as
unsafe.
Well, you could grade their papers and you could teach their classes when they slept in and help them out, but then they wouldn't give references or help out in other ways. So I think there was a lot of that. And I wish that we had talked about it. And I wish I'd gone to the few female instructors, one of whom I now know as a very outspoken feminist and about that. And I wish I had gone to talk to her in undergrad and just talked things through. So
So like advice for your younger self and
yeah, and that's advice for
recognizing
my younger self. So for you, I'd say talk to people. I think I really do think things are changing. I don't think it'll take a while for everybody to retire. But I mean, if you look around, and I talk to people who are in like analytics positions, the vice presidents and directors around Vancouver, and they are mostly men. So that's still the case now. I think younger people starting out, data scientists, there are more women in data science.
Yeah.
But it's not 50-50, I don't think.
I remember I've talked to a few friends when I was in school. It's like there were very few women like in the comp sci classes to the point like they all knew each other because there were so few of them. And
Yeah,
I understand you're saying just having like that tribe to like, you know, have like support each other, empower each other and have those conversations.
yeah,
That
I
network.
think that is good. I know there were very few women. Plus, hopefully no one says this anymore. When I was in graduate school, everyone said that all the women were there to get married because there's so many men compared to women that you can meet your spouse. So I heard of that a lot.
Yeah.
Get your MRS degree.
Yeah.
It's not a very nice thing to hear that people think that you chose your major to get married.
Yeah, that's
I did
not
not.
Cool. I agree. It's not cool. And hopefully like each day everything's getting much better. Like things like, you know, have these conversations and like workplaces changing and so on. Yeah.
I hope so.
I hope so. And yeah, I'm really glad you shared that with us because it's like part of things I've heard about like you said, it's not personally experienced, but like these conversations are happening. So thank you. Yeah.
And I will say, yeah, again, that I didn't know that like other women who went to grad school with me had things going on. And yeah, we probably could have done something had we banded together.
I agree with you 100%. Yeah. And okay, I'm just gonna move to any questions in the chat. Paula, did you receive any DMs? I see two questions, one from Steven and one from Helen.
Yep, that's all I see in the chat too.
Okay. So Steven's question was context.
Yes,
coverage.
This about the MDS, and I'm glad to see there's more business. I felt that was the thing that was lacking when I took it, but that was 5 years ago. And I know that they are building and changing. I do keep up with the MDS people, and I think they're really good people. It's been interesting watching the program grow because it started with like 19 students. The year I was there was 40 something, and now it's like huge. They really grew that. So that's pretty cool. Yeah, how am I incorporating business elements in my program? Hopefully, we try to build the program around business elements. So it's a business analytics class. So business problems are the main consideration, as well as we spend a lot more time presenting, creating proper reports. Visualizing is based on visualizing KPIs for your management, etc. So we try to be more business focused. And because it is a part-time program for a year, I think that's what takes some of that data, Python, like high tech stuff away from it is the business case.
Thank you for sharing. And the next question's from Helen. What are some decision points to consider if a person should do the PostGrad program versus applied data analytics certificate? I'm guessing this is BCIT.
Yeah, I've gotten that question a lot because I do these recruiting like info nights. So it's a question I get a lot, which means I know the answer. They're both good programs. The applied data analytics is a regular certificate, which means that you don't have any prerequisites to get into it. So you can start with anything. You don't have to have a degree. You don't have to know statistics because you can take statistics from good people, and you can do all the courses as well because it's a part-time studies program. You can take the classes in any order you want on your own schedule. They have them in different formats. So it's a very flexible program. I will say that the graduate certificate in business analytics is a grad certificate. So our admission standards are much higher. You have to have a 4-year degree, statistics, some Excel, some business experience, etc. But it's really that 4-year degree has to be the sticking point to be a graduate certificate. Everything is taught at that level where I assume that you have a full degree. And we go very quickly. So you don't get like 30 credits to explore it. You're going pretty quickly.
Okay.
So that is a different type of program. It's also a cohort-based program. So you're with the same group of people working in groups on Thursday nights for that year, as opposed to taking a flexible course as you like it. So they're different. Ours is also more business focused. The applied data analytics is more focused on the technology. There's a lot more SQL. And I think they do Python. I know they do R in the statistics class because it's the best for stats.
Okay. Good to hear. Thank you. Let's answer Alex's questions, and then we'll loop back to Lori. I'm not sure. So Alex is in a boot camp and wants to be there. So Alexis is in a boot camp, but it's so advanced they have to do a lot of additional studying afterwards. They want to, become data scientists, like I guess by beginning of next year, 2023. Do you have any recommendations or advice, like to best prepare to become a data scientist?
I mean, the one thing I would say is to look at job postings and keep track of all the skills they ask for. And those are the skills you want. In analytics, at least, because that's the interviewing I've been doing. I've been speaking to less data scientists and more data analysts in business as part of my job, and interviewing people around Vancouver, all the vice presidents, to see what skills people need. Everybody wants SQL, no matter what, for every data job. And I can't imagine there's a data science job that doesn't ask for that as well. So I would say you don't have to be like a full database of men, but you should understand relational databases in SQL. That seems to be like right now the core skill that everybody wants. You need at least one scripting language to be a data scientist. Bootcamp should be teaching you Python or R because those are the languages, but there are other ones too. If you know one, you should be able to learn another one, even if that means that you have you keep on Googling, how do you do this? Yeah. That's okay. And when I like R, and that's what I learned first. And I'm teaching a class in Python right now. And I have a dplyr to pandas dictionary that I keep on, that I bookmarked. So I can see like, if I know how to do it in dplyr, what does that mean in pandas in Python, which are the packages, if those of you don't know, because I'm trying to translate, and that's okay.
Just having the cheat sheet.
It's okay to have cheat sheets. It's okay to Google things, but look up things. People always recommend these Kaggle competitions. I think they're useful, but they're very like clean, sanitized data. But things like hackathons can be useful just because you get to meet people there and work on real projects and see what people want.
Yeah. I started, I think, as data wrangler, so clean the data, and became analyst. And I think one of my roles just before the pandemic, I was a database analyst with the credit union, so like the bank data from 1970s like till now. And it's SQL or SQL. It's like it's very, very important, and it's like a useful skill to have. And having like you saying before, like the business insight, knowing what to solve or how and where the questions are asking, because data's not clean, like where it's stored. Like
no, data isn't clean. I'm not sure if it's a good boot camp, they'll give you like messy data to practice on. So try to do that. I don't know if it's useful. They always used to say you should write blog posts and you should put projects on your GitHub. I've never looked at someone's GitHub when I was hiring, but maybe people have a lot more time than me. I've read through publications, I'll say that. But I rarely have time. Like a project has so many files, it's so difficult to review very quickly. So Yeah, I don't, but maybe other people have more time when hiring that they go through people's projects.
Yeah, like interviewing at a smaller company, a startup versus like a larger org, like you said, where some things may not change as quickly.
Yeah.
So yeah, let's hope that was useful. So loop back to Lori. Summarize. Lori's older than most of us. Okay. And you were human economics. Yeah. Oh, you have a daughter. I'm like reading really quickly. So, Amy, would you like? I'm not sure if Lori had a question, but like, I'm really interested in what Lori shared. Just kids, the daughters, engineers, taught math, and would like to see more
I
women.
agree. It is strange to me still how many professions are coded female, and then they pay less, and versus things that are coded male and then pay more. Nutrition is important, and it's a health related field, but certain health related fields tend to be coded female. My mother took occupational and physical therapy right before they opened it up to men. So only women were allowed in the program. And that is the way things were. And they still are. Nursing is mostly female. I think nutrition and dietitians, they tend to be mostly women. And there's no reason why that should be.
It's like the pink slip, I think, or what's it called? Something pink collar, pink slip. If it's like
the first computer scientists and programmers were women. It was originally a female profession, and then men took it away and they made it fancier and paid more. But originally it was women that were computers, the original programmers.
I remember they used to have like little punch cards. And that also like I was like trying to remember like seeing that like some stuff on like in the episodes of Mad Men. Well, hopefully it's like everything's becoming more diverse. Like her was that TV show Buffy, like the person who created it, they was like had a degree in like women's studies. So
which TV show?
Buffy the Vampire Slayer.
Oh, he did not have a degree. Did he have a degree in women's studies?
So I remember like reading that a long time ago, but maybe I'm misremembering.
He's one of the men that got cut out by the Me Too movement. So I hope he didn't have a degree in women's studies.
Okay, I did not keep up with that.
And I loved that show. I watched all those Joss Whedon shows because I was a teenager in the 90s. So I was, I believe, the same age as Buffy was, and she went to university when I went to university.
Oh, wow. That is like an awesome growing up experience. Yeah, oh, I see it's just like 8:05 now. There's no more questions in the chat. You can just like say thank you, everyone, especially thank you so much, Amy, for chatting questions and like on your a sick day that you had and share like I guess like your knowledge and like experience like with our community. Thank you so much.
This is really interesting. I do like speaking to people, and I used to get to do like in-person speaking arrangements, and now it's been 2 years and a bit, and it is nice to see people, even if I'm just looking at your name on Zoom.
Well, hopefully this year everything's much smoother and we eventually can transition like going back in person. But I know there's now like another variant, so we just want to like keep everyone like safe and healthy.
Another variant.
I know, right? Knock on wood.
I will say people have gotten more interested in data after and epidemiology. As your data people, you know that everybody knows a lot about data and moving averages and exponential curves now, but then they draw the exponential curve wrong, and it's still sad.
I think I saw someone drawing like the picture of like the COVID cases in Vancouver, but they make it look like a cat. Like they shaded it in and just like do like the cat face on it. It's very cute.
I'll say that this has shown us that there is a huge possibility for good data journalists, data storytellers, people that are data literate, but also can tell a cohesive story. That the really good data journalists have really helped people through this pandemic. So I think
is there anyone that you followed or
I'd say Justin McElroy here. He's in the CBC Vancouver. He does all the charts for the CBC, and I follow him.
Okay.
And there's the BC Independent COVID Modeling Group, which is mathematicians from UBC and SFU. And they've been doing like independent modeling, not like the government sponsored, though the government people are good too. And I read their reports.
Okay. Great. I'll have to like look up their information too after our call. But yeah, thank you so much everyone for joining our event tonight. Thank you so much, Amy. Really appreciate it. And yeah, everyone have a great Thursday night. Okay. Bye.
Bye.